or 1. So Boolean algebra can be given as Boolean algebra is used for minimization of logical expressions where the variable can take only two values. Boolean algebra is used for minimization of logical expressions. Okay, what is the meaning of logical expressions? Okay, and where the variable can take only two values, either 0 or 1. That is why it is called Boolean. So what we are discussing, these rules are valid when the variable can take only two values, either 0 or 1. So ultimate aim, why we should do this? Okay, first understand what is Boolean algebra, where we are applying this. Okay, why we are applying this Boolean algebra? It is used for minimization of logical expressions. Okay, so what is the meaning of logical expression? Where the variable can take two values, either 0 or 1 only. Up to this clear for everybody? Good evening, Bachanji. Yes or no? Okay. So why we are doing this? What is the reason behind this? When you minimize the logical expression, what happens? The size of the expression decreases, number of variables decreases, number of logic gates decreases, power consumption may decrease. So ultimately, you should be able to implement any given function with least possible hardware. So that is the main aim. What is the ultimate aim of the Boolean algebra minimization? Ultimate aim of minimization is to implement the system with least possible hardware, which will save your time. Namaste, Robert. Okay, which will save your hardware. You should implement with least possible gates or least possible hardware, which will save you, which will save your cost, everything. Okay, sometimes maybe more hardware required to implement faster. Fast may not be every time. Less hardware need not be faster. Okay, those things we discussed. Okay, but ultimately we should minimize the expression, because same function is we are able to implement with 100 gates or 10 gates. Which one is better means definitely you can say 10 is best. Upcome whatever you are having, your mobile devices, everything you want always know what smart, thin. Okay, as compact as possible. So you should implement your functions with the least possible hardware, provided your required conditions are satisfied. Okay. So in the Boolean algebra, we have the basic operations. What are the basic operations in the Boolean algebra? AND operation, OR operation, inverter. Okay. AND operation, OR operation, inverter. These are the three basic operation of your Boolean algebra. What are they? AND means if both, what is the meaning of AND? If both are ones, then only your output is one. You can say both the input should be one, both the variables should be one, A and B, both should be one, then only your output is one. You can say A and B both should be true, then only your output is true. Otherwise, it is 0. This is what we call AND operation. Good evening, Nidhi. Okay, no problem. But we see here. Khan, hello. Now you have the internet, right? So please see here. Any one of them is 0, your output is 0. This is what we call AND operation. Similarly, we are not discussing logic gates. Gates is the circuit which will implement this operation. That we discuss later. First, basic operations, like in your regular maths, you have plus, minus, multiplication, division, right? These are nothing but your operators which will perform some operations. Similarly, in our Boolean algebra, we have the basic three operations. What are they? AND operation, OR operation, inversion. Any function is a combination of these three only. Maybe you take 2, 1 or 3, but combination of these will make you any given function. So this is your AND. Similarly, what is OR operation? OR means A or B. Any one of them is 1. Your output is 1. Okay. What happened? Yeah, don't worry. I will modify it. Don't worry. Okay, see here. OR operation is simply any one of them is 1, output is 1. That is when both are 0, then only you will get 0. Both are false, then only you will get false. Next, NOT operation is nothing but inversion. That is 0. You represent with this bar. 0 bar is 1. 1 bar is 0. If you take 2 times bar, you will get back same. Okay. So these are the basic operations which I don't need to give much explanation. I hope everybody already knows, but I will explain. I have explained just to give you the continuity. Good evening, Balakrishna. Now see here, 1 minute. So AND operation, what is the reason? When both are ones, then only one. So what is the operator used for AND operation? What is the operator used here? Dot, right? Similarly, for operation OR operation, we are using plus. Here it is not addition. Please understand that. 1 plus 1 is not 2 here. It is not addition. It is OR operation. Any one of them is 1. Output is 1. 0 bar is used for inversion. Okay. So now some relations I want to write. You should tell me here. What is A plus A bar? What is A plus A bar? Everybody 1. Why? Because if A is 0, here plus, whenever I use this plus, it is nothing but OR operation. When A is 0, no problem, Swapnil, it is a basic class only. A is 0, A bar is 1. 0 plus 1 is 1. If A is 1, A bar is 0. 1 plus 0 is 1. Any case, A plus A bar is always equal to 1. Similarly, what is A plus 0? You see, 0 plus 0 is 0. 0 plus 1 is 1. Whatever you have here, that will come. So A plus 0 is nothing but A. Similarly, what is A plus 1? 1. Okay, 1 is present here. 1 plus 0 or 1 plus 1. Both the cases, what is my output? 1 only. So I can write it as 1. It is valid for Boolean only. Please don't, okay, take it wrong. It is valid for Boolean. Okay, and we are performing OR operation. 1 plus 0 or 1 plus 1 or 1 plus anything is 1. Lastly, A plus A. If A0, 0, here your variable has 2 possibilities. What are they? 0 or 1 only. If A0, it is 0 plus 0, 0. If A1, 1 plus 1, 1. So it is A. So can I do the same analysis for AND operation also? Definitely yes. So let's do that also. A into A bar. If A0, A bar is 1. If A1, A bar is 0. But both the cases, 0 into anything is 0. What is A into 0? 0 into anything is 0. What is A into 1? A into 1. 1 into 1, it is 1. 1 into 0, it is 0. A into 1 is A. Right. Very good. Very good. A into A. What is A into A? Not, don't say A square. 0 into 0 is 0. 1 into 1 is 1. So A into A is nothing but A. Similarly, one more thing. You can say A bar whole bar is nothing but A. What is A bar whole bar? It is equal to A, because A bar is 0 bar is 1. 1 bar is again 0. So is it clear up to this? It is nothing very basic conditions. Okay. So let me use them and go to the next level. Okay. So in the Boolean, I want to give you one point. In the Boolean, okay, AB equal to AC. Then can I say what is the relation I can draw from AB equal to AC? What is the relation between B and C? Please type. Type. Everybody. B not equal to C. Okay, in Boolean, never apply AB equal to AC is given. Don't strike A and B, A and A both sides, and don't take B equal to C. Okay. right? So listen here. Why? Because if A equal to 0, okay, so 0 into B equal to 0 into C. Both are zeros. B need not be equal to 0. 0 into anything is 0, right? You take B equal to 1, C equal to 0. Yes, 0 into anything is here. A is can be 0 also, because your variable is having two values only here, either 1 or 0. They can be equal, but they need not be equal every time. Okay. If A equal to 0 condition, if A is 1, then maybe B equal to C. So it depends on A value. Okay. If A is 0, you cannot say directly. So in Boolean, if you get this kind of relation, never cancel both of them and say B equal to C. Okay, be careful with that. It depends. It depends. Okay, it depends. We cannot say B equal to C. It depends. Yeah. If it, actually it not depends on A also. It depends on ABC value. There is no strict rule here. If A is 1, you can say B equal to C. If A is 0, it depends. Maybe BC equal also. It depends on what are your BC values. So let's take one small example on this. Yeah, read the question. Find the Boolean variables A, B, C which satisfy the following relations. What are they? A plus B equal to 1. Not independent, Manjunath. A can be 0 also. Yeah. If A equal to 1, why cannot say? You can say if AB equal to Manjunath, if AB equal to AC and A equal to 1, then definitely B equal to C, no doubt in it. Only number system is completed. Swapnil, this is new chapter. Today is the first class. Yes, if A 0, it depends on BC values. There is no strict rule here. If A 0, it depends on what are your BC. So leave that. Let's come to this question. So find the Boolean variables A, B, C. Okay, you are giving your answers. Okay, let me check it. Satisfy the following three functions. A plus B must be 1. AC equal to BC. A plus C equal to D. AB equal to 0. Now see, can I say A, B? Can I cancel it here? C, C. A equal to B, can I say? I told already, don't do that. Okay. It depends. It may be equal also. We don't know. So what to do? See here. Take the first one and last one. I will give you different way. People can apply different approach. I am giving this approach. A plus B equal to 1 and AB equal to 0. What does it mean? Please listen first. Don't worry about your commenting your answers. Just listen. First concentrate. Okay. Concentrate on the approach. Concentrate on the approach. Don't do compliments and all. Okay. Simple thing. If AB, if A plus B equal to 1 and AB equal to 0, it means A comma B equal to either 0, 1 or 1, 0. This is how we can start simply. Yes or no? Because if both are, if A plus B equal to 1, there may be 1, 0, 0, 1 or 1, 1. AB 0, it can be 0, 0, 0, 1, 1, 0. If you take both are to be satisfied means only this case. It cannot be 1, 1 because 1, 1 will give you A into B as 1. It cannot be 0, 0. 0, 0 will satisfy this, but it will not satisfy this. So both should be satisfied means it should be either 0, 1 or 1, 0. Now, so AC equal to BC and A plus C. If you take A equal to 0, I don't know. I'm just assuming. I don't have any option. I just assumed. Okay, two possibilities I assume. Then AC equal to BC. So substitute A value 0 into C equal to 1 into C. What is the C answer? 1 into anything is C. So C equal to 0. This is one answer. Then this I have taken second one. Now take the third one. Third one, if you take A plus C equal to 1, is it satisfying? A plus C equal to 1. A is 0, C is 0. It is not satisfying. So you can say this is wrong assumption. So you should start reverse. If A equal to if A equal to 1, B equal to 0, then take this equation, second equation, AC equal to BC. Substitute here, 1 into C equal to 0 into C will tell me C equal to 0. Okay, next, if you substitute that, for what is the third point for us? A plus C equal to 0, right? A equal to 1 plus 0 equal to, sorry, A plus C equal to 1. I'm sorry. So true. So it is satisfied. So what is the answer? A equal to 1, B equal to 0, C equal to 0. These are the, this is only satisfies here the required condition. Okay, it's a simple question. It's given in one of the ES paper earlier in the, I think, conventional. So is it okay? Shall we proceed further? Right. So in the Boolean algebra, we have different properties. So we are discussing Boolean algebra properties. Okay, the first one here we are going to discuss commutative property. This property you might be knowing in your maths already. In your maths, okay, what is commutative property? A plus B equal to B plus A. A into B equal to B into A. 2 into 3 equal to 3 into 2. Whatever may be. Okay, here our plus is nothing but OR operation. Okay. We need to explain Nishita. Means whenever you assume something, you should give that assumption. Like here, this is not satisfying you. So we should write the supporting statements always. Okay, come here. Now, commutative property says that A plus B is always equal to B plus A. Similarly, A into B is always equal to B into A. Similarly, I can also say A plus B whole bar is equal to B plus A whole bar. What is this, sir? Inversion of R. What is this operation? R. What is this? And inversion of R is called NOR. Inversion. Whole bar. Bar means what? Complement. Na? So complement of A plus B is equal to B plus A. Similarly, A into B complement is equal to B into A complement. That is what we call inversion of AND. We represent with NAND. Two more special functions are there that we will be discussing in the next continuation of this class or tomorrow class. XOR and XNOR. This is the symbol for XOR. We will discuss this. Don't worry. Okay. What is XOR? Everything we will be discussing clearly. And XNOR. Everything. All of them. All your logic functions. Okay. Will logic operations satisfy XNOR. Sorry. All satisfies commutative property. Up to this clear for everybody? All satisfy commutative property. Now, is there any case where this commutative property is not satisfied? Yes, there are the cases where this commutative is not satisfied. Nanda, you take the truth table of A plus B. For example, see here, you take AB, A plus B, and B plus A. Right here 0 0 0 1 1 0 1 1. Okay. Now add A plus B. or add B plus C. Plus in the sense OR operation. You will be getting the same answers now. Yes or no? Which will similarly you can prove all the cases. Okay. As if those are arithmetic operations, division and subtraction. Here it is not addition, my dear friend. It is OR. It is not multiplication. It is AND. They are here. What we are discussing is the logical operations. Okay, Asif. Those comes under arithmetic operations. So all these satisfy commutative property. So where this commutative satisfier fails, commutative property fails. That is important. Listen here. Most of you might know this, but you may or may not know this. Let us see. The next one, implication. Similar to AND operation, OR operation, there is one term called implication. Please refresh, Vivek. Okay, what is implication? What is the meaning of A implies B? What is the meaning of A implies B? It is A bar plus B. Okay, so let's draw this and explain you clearly. Sorry, A. What is the meaning of A implies B? It is A bar plus B. So if A is, if they can be 0, 0, 0, 1, 1, 0, 1, 1. Okay, so what is A bar plus B? Please tell me. What is A bar plus B here? 1, 1. A bar is 1 bar is 0. 0 plus 0 is 0. 1 bar is 0. 0 plus 1 is yes. 1. Now, please listen here. I want to prove one thing. What I want to say here is when A is true, what is the meaning of A implies B is when A is true, your output same as B. See here, when A is true, your output is same as B. What is the A implies B? If A equal to true, output is same as B. Now what happens when A is false? It is a constant. It can be anything. Here it is 1. Okay, it is a constant. When A is 0, it is a constant. When A is true, output same as B. This is what we call implication. Like AND operation, OR operation. This is also one operation, implication. So yes, 1 is for true, 0 is for false. Right. So now listen here. Here what I can say. A implication B truth table will not be equal to B implication A. You can prove it also. What is that? A bar B is not equal to B bar plus A. So these are the conditions where your commutative property is failed. Implication does not satisfy commutative property. Okay, implication does not satisfy commutative property. Similarly, there is one more case called inhibition. Inhibition B, which is nothing but A into B bar. You can simply say it is nothing but A but not B is the way you can say A inhibition B. What is the meaning of A inhibition B? A but not B. What is B inhibition A? What is B inhibition A? It is B but not A. And you can say A inhibition B is not equal to B inhibition A. So not satisfy your commutative property. Sir, why these new rules, sir? Till now we studied only AND gate, OR gate, NAND gate. How these new things came? Will they come in our exams? That is your first point in your mind. Sir, ये exam में आएगा. Listen here. Listen here. Where is that? Why I click right like this? 1 minute, please. Right. So please listen that I am discussing this in last 4 years or something before GATE 2015 also. But okay, that is also another question, Shivam. You will be getting immediately after anything you learn. First thing, whether to remember or how to remember, sir. When you apply it, you will get remember automatically. Okay, I will explain, Chaitanya, just wait. Okay, one thing I want to say, I am discussing this from more than 4 years also, but 1 year recently, just before I think 2016 or somewhere, there is a question based on this, not directly, indirectly they have given. They have given this implication gate, and later means maybe today or tomorrow class, I will discuss universal gates. What are the universal gates, you know? Might be some digital, if you know already, you can say NAND NOR. Not only NAND NOR, these are also not XOR, my dear friends, NAND NOR, right? These two also universal gate. That's why it is important. Implication and inhibition are universal gates. I will prove it. I will explain it later. Okay. Is it clear? Vivek, just wait. Let me complete my explanation. Okay, right, Sura. Implication, inhibition are also universal gates only. That I will prove it because one of the gate paper they have given some gates. 4 gates they ask, they give the figures. They ask which one is the implication. So which one is universal? This bit appeared in the gate. Before that, it is in my notes. Why I am saying because I don't know what examiner asked. I don't say like that. Definitely because a similar question appeared in 1990. Okay, so I guess that. So I kept in my notes. So that is repeated. So earlier also in 1990 somewhere there is a question on implication. That also we'll do it in our class later, maybe today or tomorrow. Okay. So those question papers are important. Earlier 1990 somewhere, okay, most people will neglect it. Most of your DPP comes from that part for enough practice of it. Okay. So 1990 somewhere one time it appeared. Okay. I kept in my mind. Similarly, 2015 or 16 it appeared again. Okay. What is that importance of implication inhibition? They will act as a universal gate that we discuss later. Now, thank you, Subra. I don't feel it is very good, but okay, you are able to read. I am happy for that. Now where we are? Now, listen here. You may have the doubt. What is the meaning of this inhibition, sir? Let me explain. Let me explain with the help of your school. In the school days, you might have studied these 5 figures or not. Yes. Hmm. Venn diagrams, right? Venn diagrams. Okay. So if you take this as A, this as B, and what is this common area, my dear friends? What is this common area? It is A intersection B. We call it as A into B. Now, what is this white color area? That is, I am marking it as a blue color part. What is this part? Only A, right? Very good. Only A is nothing but A, but not B. We call it as AB bar. This is nothing but your inhibition. Okay, it is in A, but not in B. This area, this one. Okay, this part is in A, but not in B. That's why it is called AB bar. We can another name of this is exclusively A. Later, if you use this, we will get one gate called as exclusive OR gate that I will discuss later. Okay, just wait. So similarly, what is this part? It is B, but not A. So here Yeah, only B are exclusively B. So if you add these two, you get one new gate called as exclusive OR gate, AB bar plus A bar B. That we discuss later. Okay. So that is what we call implication and inhibition. Is it clear for you? Can I move further? Someone has asked some other doubts. What is the meaning of implication? If A implies B means if A is true, output same as B. Saurav, here we don't have minus. Okay, in the boolean, you are in your sets and relation, you might be using that minus and all. The here notations will change. Their intersection here dot operation. Their union here plus operation. Simran, please refresh. What do you want me to repeat, Bhargavi? Please tell me. I will repeat. Implication. A implies B means see the truth table. Whenever A is 1, your output is the same as B. What is the meaning of A implies B? Whenever A is 1, output is same as B. That is the meaning of A implies B. Okay. So let's move. Only in A. Sushil, it is only true if it is A. It is only true if B is true. If you take exclusive OR, your answer should be true for only A condition should be satisfied, B condition should be satisfied, not both. Exclusive means only in A. Okay, right. Let's move further. Now I can write this point. Okay. Let me write this point. All logical operations AND, OR, NAND, NOR. Bhavesh, you can write it. What is there? Just multiply A into B bar. Okay, A into B bar. B is 0, take 1. 0 into 1, 0 into 0, 1 into 1, 1 into only for this you get 1. Only for 1 0 you get 1. Remaining all you get 0. A should be 1, B should be 0. Now please see. All logical operations AND, OR, NAND, NOR, XOR, XNOR satisfies commutative property. But implication and inhibition does not satisfy commutative. Okay, remaining all will satisfy the commutative property except implication and inhibition. So the next one, associative property. See here, associative property. What is associative property, sir? Order is having any meaning or not? That is what we call associative. Please see. You have three variables ABC. Here plus means, please remember always our plus means what? Plus means what? Or. Okay. So B plus C you add first. That is here first you perform BC, then you perform A. Or first you perform AB, then you perform C. Both the cases your answer is same. That is what we call associative. Okay. Similarly, you perform A into BC first or AB into C next. Any method will give you same answer. These are what we call associative properties. What is the advantage, sir? Listen, I will explain this later, but just for continuity, I am drawing the figure. This figure meaning everything, we'll discuss it next. Okay. If you take OR gate, what is OR gate, sir? Everything we'll see. You do A plus B here, and at the output, you connect C. What is the answer? A plus B plus C. Now you take first A and take here BC. And what is the answer here? A plus B plus C. And similarly, you take 3 input A, B, C. This is all are same. So if it satisfies associative property, okay, you use two input gates to make 3 input gate. This is true for OR gate and gate. Gates we have not discussed. Just for continuity, I draw the figure. Forget about it if you don't know what is gate also. Don't worry about it. Okay, I will discuss that anyway. So next, which will not satisfy this associative property? Listen. NAND and NOR does not satisfy associative property. NAND and NOR does not satisfy associative property. Why, sir? Listen here. Let me prove it. You want to perform A, B, C. Okay, if you do these two whole bar and this bar, it is not equal to. Is it okay what I am saying? And this is not equal to A, B, C whole bar. All are different. All are different here. This is a, similarly, you take NOR gate also. A plus B this will also not satisfy associative property. Okay, so what we can say, NAND NOR does not satisfy associative property, and OR will satisfy associative property. Listen here, 1 minute, 1 minute. Okay, you can prove it by taking any example if you want. Okay, XOR XNOR satisfies associative. Okay, here for this little explanation is required. Just wait for some time. That is when we discuss XOR XNOR tomorrow class, then I will prove all those conditions. Just for timing, note it. Okay. Now listen here. Now listen here. There is one gate previous question like this. Which of the following is commutative but not associative? Which one is commutative but not associative? NAND and NOR are commutative but not associative. Anyway, these are not commutative, these are not associative also. Forget about these things. Okay. I am saying about this. NAND and NOR are commutative but not associative. Okay, very good. So let's move further. Next one is distributive property. What is distributive property? A into B plus C. Let me go a little slow. If you feel fast, A into B plus C is equal to, multiply this, AB plus BC. It is true anywhere in the universe. For this, you don't need any extra understanding. AB plus AC, right? I'm sorry. Yeah. No, deep. I said, na, implication inhibition does not satisfy the associate. AB plus AC. Okay. So now next one is what? This is important for problem solving. This is very important. A plus B into A plus C equal to A plus BC. Okay, let me prove it. It is not valid every time. This is valid only for Boolean. So everybody see here, A into A into C, AC, B into AB, and B into C, BC. Okay, this is your expression. Now here, take A common in all the three. What is 1 plus anything, my dear friends? Tell me 1 plus anything. 1 plus anything is 1 in the Boolean algebra, not for the other cases. In the Boolean, it is 1. So you can write it as A plus BC. So A plus B into A plus C is equal to A plus BC. This will help you in your problems. Let me give you that example. If you have A plus B into A bar plus yeah, A plus A bar into B. If you have this kind of expression. Now, according to this rule, how I can write it? A plus A bar into A plus B. Yes or no? X plus YZ equal to X plus Y into X plus Z is our rule. So A plus A bar will become 1 and A plus B is the answer. This is valid for Boolean only, not every single case. Okay. So please remember this carefully. You will be using this in your problems easily. No problem, Abhijit, I will repeat. Okay. In the Boolean algebra, 1 plus anything equal to 1. 1 plus 0 or 1 plus 1. Both the cases 1 only. Similarly, 1 plus 0 plus 1 plus anything. 1 plus anything is 1. 1 plus b plus c, whatever may be, is equal to 1. Now let me write the different variations in this expression. Different variations like this and tell me the answers. You tell me A plus A bar B bar. What is the answer? Please tell me. Please comment. Okay. Yeah. A plus B bar. Next. A plus A bar plus AB. Now tell me. Is it clear? Same rule if you apply A plus A bar into A plus B bar will come. Answer is A plus B bar. What is A bar plus AB? A bar plus A into A bar plus B, which is A bar plus B. What is A bar plus AB bar? A bar plus AB bar. A bar plus A into A bar plus B bar. A bar plus A is, this is 1. My dear friends, please remember, this is 1. 1 into anything is anything. Done. So similarly, what is the answer? It's A bar. Don't apply here the same rule again. Okay, you should see A and A bar, then only rule is valid. Here it is A bar, you take common 1 plus B. What is this? A bar, you take common 1 plus B. 1 plus anything is 1. Answer is A bar. Okay, so here don't apply that rule. Okay, don't apply the rule, previous rule here. Okay, so be careful. You should see one variable, its complement, or a complement and variable. Then only you can apply. Everybody, is it okay? Can I move further? Abhinav, it is very simple. Please, Abhinav, you use this distributive property. A plus A bar B is, see, if you have X plus YZ in the Boolean algebra, it is equal to X plus Y into X plus Z. I use the same rule. That is here what we got it. Please listen. A plus A bar B equal to A plus A bar into A plus B. A plus A bar is 1. 1 into anything is A plus B. That's all, Abhinav. What if we apply? It should be same. I didn't get you, Simran. You should see variable and complement, then only apply it. Otherwise, you cannot apply this rule. कहाँ सेम आना चाहिए? Last वाला or which one? Last one में this is completely different to the previous 3 cases. Please understand. This is completely, these 3 and this is completely different. Okay, this is another example where you should not apply this rule. 1 plus b is not vanished, my dear friend. 1 plus anything is 1. What is 1 plus b? 1. So a bar into 1 plus b is a bar into 1, which is a bar. Okay. So this is just to give you the understanding. Here you cannot apply the rule. Okay. Fine. Now in the formula there is a 3 variable, but in this only 2. So okay. Here also every case variables are variable does not matter. Okay. I am writing every single point, Rohit. Okay, don't worry. Don't remember. Okay. I am providing you the notes. Just read the notes. Every single point is in the notes. No need to remember. It is not possible to remember also. Okay. So that's what I am saying here. This example, if you see, it is enough. Ruchita, you want to apply here the same rule. It is not possible because you have a bar but not a. If you want, you can do like this: a bar plus a bar into a bar plus b. Like that you can do if you want. If you want, you can do like this. I am saying this absorption will not happen. Is it clear what I am saying? If you want, you can use it as x plus y z, x plus y into x plus z. This thing will not happen. That's what I am saying. Okay, fine, fine. Okay, this reduction or absorption is possible only when you have a and a bar. I'm highlighting this part. Okay, so let's move further. Okay, listen. This is very important exam point of view or analysis point of view for reducing the number of gates also. Consensus law. It's not nonsense, consensus. Okay, it's a consensus law. Okay, what is consensus law? If you have AB plus A bar C plus BC, it is always equal to AB plus A bar C. You can remove the last term. You can remove last or one term from this expression. So let me prove this first. Let me prove this line. How to prove it? AB plus A bar C plus BC. I want to prove this expression is equal to this expression. Then I will tell you how to remember this also. Okay. Now tell me here. This expression as AB plus A bar C plus BC. Here I will add one term. You tell me whether it is correct or not. A bar plus A plus A bar. Sir, can I do this? Yes, A plus A bar is 1. 1 into anything is anything only. So you can multiply with this. It will not affect your answer. It is same. Okay. So now what is your answer? AB plus A bar C plus ABC plus A bar BC. Now see here, in these two, who is common in these two? Tell me, in these two, who is common? Yes, AB into 1 plus C. 1 plus anything happily neglect. Similarly, in these two, who are common? A bar C into 1 plus B. So 1 plus anything is 1, neglected. What is the answer? AB plus A bar C. It is proved. If you have AB plus A bar C plus BC is equal to AB plus A bar C. How to remember this, sir? Okay. It is your favorite question, right? How to remember, sir? I will tell you here how to remember. Last term means if they shuffle to first term, if they shuffle this to the middle, then okay. So listen here. How to remember easily is in the consensus law, you have 3 terms. I will write these points. Don't worry. Just listen. Everybody every time don't worry how to remember and all those things. I will write. Okay. Every required point I will definitely write. Okay. So Nation wants to hear from me, right, Abhijit? A, B, A bar C. Here you have three terms. In one term, you have a variable A. In one term, you have a variable A. In the second term, you have its complement, A bar. You have a variable, its complement. The remaining, Baki, whatever you have, remaining what you have, these two product is there, this will become redundant according to this consensus law. If you have variable, its complement, remaining part product will be neglected. Okay, so you have a variable, its complement, whatever the leftover, its product is here, that you can neglect it when you write the consensus law. Is it okay? For your practice, can I give you one example? Let me give one example. It will make it very clear for you. I'll conduct the poll. Get ready. Get ready. I will be conducting the poll. Okay, I will explain again. Don't worry about it. Okay, from this you will be able to understand. That is my intention. Are you ready, guys? Okay. Can I expect 100% result this time? At least I will expect expectation to free. Good. Good number of right answers. Very good. I am happy for that. I am very happy. At least 85% given right answer. We should see like that. So, आज का फर्स्ट पोल सागर, अभिनय, हर्ष, सिमरान, अमिताभ, अभिजीत, मोहन, रोहित, कृणाल, Konal. Very good. Okay. So the right answer is this one. So now remember the thumb rule happily. See here. You should have a variable and its complement. Variable and its complement. Remaining part ka product is available here. Remaining part. What is the remaining part? Q and R. Remaining part ka product is available. It may be in the middle. It may be in the first. Don't worry about the order. Okay. मेरा पास एक variable. I have one variable P, its complement P bar, and whatever the product remaining part is Q and R, na, its product is available. Neglect this. Yes, this is what we call redundant. That can save your gate. Number of gates will be reduced if you neglect this, because this is same as P bar Q plus PR. If both are same, go for this only. Yeah, we can say it as redundant, and what is the advantage of redundancy, etc. We can discuss as this in hazards. One topic is there I will discuss again. Okay, so redundancy here, this is not the only case of redundancy. There are different cases of redundancy. Okay, so please listen here. Now let me come back. So let me write the points so that it will be very clear for you. I could have typed. So to identify consensus law. Okay, first three terms must present. Okay, next we have one variable, variable and 1 minute, let me write it clearly. Variable in one term, its complement in another term, comma, product of remaining as one more term. Okay, then we can neglect product of remaining term, that we call redundant. So these are the three rules to identify consensus law. First fundamental rule is you should have three terms. So let me take n number of examples now. You will be able to identify it easily. Just wait. Okay, so this is another way to write this consensus law using we call SOP and POS that we discuss in the later midterms max terms topic. Okay, A plus B, you see three terms, A plus B, A bar plus C, B plus C. Other side, you can neglect the term which is you can say it's a dual we call. Just next we will discuss this. Okay, for time being just leave it. Now come here. Let me write it. Okay, now you should tell me AB plus AC plus B bar C. What is the answer? What is the answer? Just comment. Just comment. Very good. Very good. AC is the redundant. So what is the answer? AB plus B bar C. Yes, your job is done. Very good. Because you here only one variable is in normal and complementary form, that is B bar. Remaining you can neglect. Is it okay? So shall I proceed further? Very good. So let's move further. A bar, B bar, AC plus B bar C. Now tell me what is the answer. Very good. That's all. This much easy. So A bar and A. You should check first what the variable which is in both normal and complement. So I'm writing always check for variable which is in both normal and complementary form. This happens to only one variable. Okay, it will not be like sorry A bar B bar and I will take A C bar and B bar C. Then it is possible or not. Let me check it. So please see here first. A bar A. Remaining whatever you have you can neglect. What is the answer? A bar B bar plus AC. So let me write one more example. One more example. What is the answer? Yes, it's not consensus law. Do not apply here consensus law. You should apply any Boolean algebra expressions and do it, right? Okay, here you see A is changing to A bar into A, and here the product is not B bar C bar. You cannot apply. Or you check here C is changing to C and C bar. Then the product is not equal to A B bar. You cannot apply here. These conditions you cannot apply. So what you need to do? Three terms are there. Okay, happy. Okay, try it. You cannot apply in any way here. Okay, You should have three terms. Okay, here you should do normal Boolean algebra only. You take a common a plus a bar something. What here take b bar common like that only. But you cannot apply this blind rule of consensus. Consensus is applicable. You should have three terms. Okay, one variable should be only one variable should be in both normal and complementary form. Other can be in any form, but not both. Okay, always check for the variable which is both normal and complementary. It will be only one. It must be only one. Right. So let me give you a little twist. One more. Are you ready? Xy plus x bar z plus v w u y z. What is the answer? Can I apply or not? Very good, very good, very good. So you can apply here happily xy plus x bar z. Okay, x y x x bar yz is there sufficient for me. Remaining here a b c d e f whatever you have your name also there. Let me write your name, Pupul. Like this also it is there. Don't worry about it. Okay, it doesn't matter. So why? Okay, if I say like that, you don't accept me. I know because you don't trust me. So let me prove it. So x y Pupul redundant हुआ क्या? Thank you, thank you. So here what to do is remember the fundamental derivation I have done. If you have b and c, multiply with a plus a bar. Let me do the same thing. But you should know the logic, then you will be very happy, right? So let me prove it with logic. X plus, yes, nice Asif. X plus x bar. Okay, so what will you get? Xy plus x bar z plus x u v w y z plus x bar u v w y z. So now you take xy common 1 plus here xy common na take 1 plus u v w z. In these two take x bar z common 1 plus tell me 1 plus u v w y 1 plus anything is 1. So what is the answer? Now onwards you don't have the problem with the consensus law. Now whatever they give, whatever the way they give, you will be able to answer. Keep our rule in mind, that's all. You are changing the name, Shivam. Okay. What, Kunal? Proof is also needed for what? You are asking again the same question for exam? Okay. Don't worry about exam, my dear friend. I am asking, okay, to understand proof is required, na? Okay. If you know the background, always it will be happy for you. Right. Very good. So let's move further. Whenever you know any shortcut, if you know the reason for that, then you can understand properly when you can apply, when you cannot apply. So one more, let's see. So it is also a previous gate question. Wxz plus w bar yz plus xyz. What is the answer? I think around more than almost 10 questions appeared based on this consensus law. That's all. Need not do much. Very simple. What is the answer? Variable Complement, remaining product is there, xz into yz, z square will not there. Here z into z is z only. So it is wxz plus w bar yz. Your job is very simple now. Is it okay? So you are able to identify consensus happily now onwards. Okay. Sometimes they will give in like a gates, like that they will give like this, w x z. Okay. To make the things complex for you, they may give something complex circuit like this. Okay. X, Y, Z. They give figure like this. Okay. And they will ask you which gate is redundant. So it is a previous gate question. So which gate is gate symbols we will discuss later. Okay. Next. Which gate is redundant? It is 3. In my class, I always assume you don't know anything. I mean, I don't assume you have already studied, and I don't start. I start from the basic only. Okay. Even these symbols also we discuss in the class. Okay. Kumari, any doubt? Expression is very simple. W. Thank you, Manjuna. W bar. Here xz, yz. Multiply both. This is coming. So whenever you have variable, its complement. Remaining part is producted. Okay. Remaining part is product, then it can be neglected. Simple. Okay. Right. You can take direct z also common. That is also okay. Very good. Very good. So next, transposition law. AB plus A bar C equal to AC plus A bar B. Nishita, whatever, you can apply it. If you have here X bar, no problem. This remaining part product should come for us. Then only we can apply. Okay, AD, which center? Indore? Bhopal, okay. Bhopal means I thought, I think 3-4 years back. 17 or somewhere. Ah, right. Okay, let's proceed. Thank you. Now see here, transposition law. So how to write the transposition law? According to transposition law, A plus B into A bar plus C is simply multiply these two and these two. This much simple. Oh, Ashish, I think I remember you. A bar B plus ACE. This is the answer. So how to do this, sir? How to prove it, sir? Listen, I will prove it. Expand this expression. A into A bar. A bar into, sorry. A into A bar, A into C, B into A bar, B into C. Now listen, A into A bar is how much? A into A bar is 0. Now it is a simple consensus law only again. It is A bar, and remaining product is, so what is the answer? AC plus A bar. So according to this transposition law, if you have variable here and complement here, in this case only you can apply it. Don't apply this for AB plus CD. Okay, here don't apply it. You should have a variable in one term and complement. Please remember that. Okay, right. Variable in one term and complement in other. Okay, now listen here. Let me write one more. Now tell me the answer for this. X plus y into z plus x bar. What is the answer according to that consensus, sorry, transposition law? Please tell me the answer for this. Here it is just these two and these two. Tell me what is the answer here. Very good, very good. Why is it here? Why z is wrong? Okay, don't multiply here middle two and last two. X into x bar is 0. No. Here your answer is like this. Okay, what is the answer? Xz plus x bar y. Examiner may interchange. Okay, to confuse you, you should see variable complement. Multiply variable other than complement. Complement other than variable. That is the rule. Don't remember as middle and last. Remember like this: x into don't multiply x bar other variable. X bar into don't multiply x other variable. Okay. I hope I think everybody gave right answer only. Remember like this. Don't confuse. Okay. So let's move to the next one. The next one, listen. Duality principle. This is also very important throughout the end of the course. We are seeing this duality principle. This duality principle not only here in all subjects it is there, right? In networks it is there. In inductor, capacitor, resistor, conductor, voltage, current. Okay. In your signals and systems it is there. Time domain, frequency domain, like that. Okay. So previous, what is the problem? See here, variable and its complement. Variable in one term, complement in another term. Whenever you see this kind of expression, multiply variable into other than complement. Complement into other than variable. Okay, similarly here also. Variable here in one product term, complement in other product term. Multiply variable into other than complement. Complement into other than variable. That much simple. Okay? Yes. So now let's start the duality principle. According to the duality principle, any logic function remains valid even though AND interchanged with OR, that is AND and OR are exchanged with each other, comma, 1 interchanged with 0, that is 1 and 0 are exchanged on both sides. It is used to convert positive logic into negative logic and vice versa. What is the meaning of it? I will come back. Okay, I will prove it. First, let me prove this condition. Please remember carefully. Let me take one expression. A plus A bar B. What is the answer? We just now discussed now. A plus A bar B into equal to A into B. A plus B. What is this? Absorption, right? In the distributive property we discussed. Now, A into, according to duality principle, you replace this plus with dot. And here you have dot, right? Replace with plus. Here also replace plus with dot. Still, that relation will be valid. That's what the duality principle is giving. Check it. A into A bar is how much? A into A bar is 0. A into B is 8. Similarly, you have A plus 1 equal to 1. A plus 1 equal to 1. So from dual, you can say if this is valid, definitely this must be also valid. Correct or not? I replaced plus with dot, 1 with 0. Again, I got the valid relationship or not. A plus 1 equal to 1. Then A into 0 equal to how much? 0. This is what we call duality principle. According to duality principle, in both sides of the expression, if you replace plus with dot, dot with plus, 1 with 0, 0 with 1, still the relation will be valid only. If this is true and this is also true. Same way you can go back to consensus law. You see here, I replace dot with plus, plus with dot with plus, plus with dot, both sides. Still this relation will be valid. This is what given by duality principle. Is it okay? Now let me give you one more example here. If you have a function f of ABC, according to duality principle, what is f of ABC? What is f of ABC? Let me take one example. Some randomly I am taking a bar, b bar, c, a, b, c bar plus ABC. Some randomly I am taking. What is the dual of this function? What is the dual of this function is a bar plus b bar plus c into a plus b plus c bar into a plus b plus c. So now what is your doubt? You can ask. This will tell you dual of the function. Okay, just wait. If you take 2 times dual, again you take dual of this function. What is the answer? A bar dot b bar dot c plus a dot b dot c bar plus ABC. This is same as original function. In networks also same, here also anywhere 2 times dual if you take, you get back same function. It is not complement, my dear friends. Don't confuse this with complement. Here you are not changing the variables. You are taking the variables as it is. Don't confuse. Is it okay what I am saying? 2 times dual will give you same. Now please listen. 2 times dual of any logic function gives same function, but there are some cases where one time dual itself gives same. Those are called self-dual functions. Those are called self-dual functions. What are self-dual functions? One time you apply dual, again you get back your original function, then it is called self-dual function. Okay. Simran, what is your doubt? Please ask me in this slide. Clear ho gaya? Fine. So 1 minute please. Let me give you self-dual example of self-dual. If you have a function f of a, b, c equal to, I am giving one example. Later I will tell you one simple rule to identify this self-dual. Okay, when we discuss the SOP POS, any function is given within within very less time, you will be able to find whether it is self-dual or not. The technique will discuss it. What is the dual of ABC here? A plus B into B plus C into A plus C. What is the answer, my dear friends? Tell me. Expand this expression. B is common here. B plus AC into A plus C. Now just expand it simply. Kumari, I am doing the same thing. B into A, B into C. AC into A is AC, AC into C is AC. So what is the answer? AB plus BC plus. What happened? What is this F? Yeah. F means I thought it is false. F is the same as original function. I am checking where I am false. Okay. So this is your function. This kind of functions are called self-dual. Sir, one more. You want one more example? F of A, B, C equal to A bar, B bar, B bar, C bar, A bar, C bar. Okay. This is also self-dual. For timing, take only these two. If you want third function, fourth function, just wait for some time. I will give you all the different possible self-dual. Just when they give, you will be able to identify. I will give you the method for that. Okay. When we discuss the SOP POS, sum of products and product of terms. That topic we'll be discussing that part. Okay. So now what is self-dual? It is clear for everybody. What is self-dual? And yes, Nishita, I will come to that point also. Okay. So just wait for some time. Firstly, what is the simple rule I told here? It is used to convert positive logic into negative logic and vice versa. What is this positive and negative logic? I have a AND gate in the positive logic. Then what will be the, how it will work in the negative logic? Right. So let's understand this concept of positive and negative logic. Listen here. And will not become NAND. Okay, positive negative logics are not complementary. They are not complementary. Please, my dear friends, remember they are not complementary. Don't confuse. Now I will give all your misconceptions clear. I mean, I will clear all your doubts. Just wait for some time. Positive logic. Out of the two available voltage levels, wait. In your computer, how you are representing ones and zeros to your memory IC or whatever CPU, you are representing ones and zeros with two voltage levels. It may be 5 volts, 0 volts, any two different voltage levels. Computer will understand one voltage level as 1, another voltage level as 0. So when one particular voltage comes, it will do one job, another voltage, it will do another job, like 5 and ground. Okay, it depends on the logic family. So out of the two voltage levels, when you more positive is used to represent one. Okay, please understand, computer don't know you are representing it as 1 or 0. Computer know only voltages. It will do its job according to voltages. Right? Computer don't know, sir, 5 volts is 0 for me, so you should off. It won't take. It will work according to voltages only. But you are saying this 5 volts is 1 and 0 volts is 0. Then this is called positive logic. I'm repeating, see. Out of the two available voltage levels, more positive is used to represent 1. Then it is positive logic. If more negative is used to represent 0, then it is positive logic. You understand that? Okay. Similarly, if you do the reverse thing, what is the reverse? More positive is used for representing 0. More negative is used for representing positive. Then it is called representing 1. Then it is called negative logic. Wait. Always statements will be confusing only. That's why we should understand with the help of example easily. So come to the example. So logic 0 is 0 volts. Logic 1 is 5 volts. You just simply tell me one thing, 0 and 5, which one is more? Which one is more positive? 5 is representing 1 or 0? 5 is representing 1 or 0? 1. This kind of logics are called positive logics. Now here tell me, now come here. 5 is representing 0. That is when 5 volts, my system will read it as, I am designing the system like that. When 5 comes, you work like a 0. This is what we call negative logic. Similarly, now come here. You have both negative. So positive negative voltage is not having anything to deal with positive and negative voltages. Don't confuse. Okay. Voltages can be positive, negative, mix. It doesn't matter. Now just listen. Out of these two, -2 and -3, which one is more positive? Tell me that first. Out of -2 and -3, which one is more positive? -2. That is representing 0. Then it is negative logic. If -2 is representing 1, then it is positive logic. So if you have a circuit, in that circuit, how you are taking ones and zeros in the output and input, then that will tell you whether your system is working as a positive logic system or negative logic system. Okay, is it clear now? Shall we proceed? Okay, let me proceed. Let me proceed with the next one. Let's take one example of OR gate. Assume I have an OR gate. No need, Preeti, I will give you shortcut. That's what I said. Now I will give you shortcut to solve within less than 1 minute. You will be able to answer. Even complex function, you will be able to answer it easily. That I will give may not be today, maybe tomorrow or next class. When we discuss SOP POS, there I will give you. So OR gate you take. If you take OR gate here, what is the answer? Everybody know this OR gate expression. Na? Now I designed OR gate in positive logic. Now I am using it in negative logic. How it will work? Let me prove. Okay. So earlier 0, you understand here. Earlier 0, now it will become what? Previously 0 will become now 1. Previously 0 will become 1. Now you observe the difference first. Please observe the difference. In complement, only output is changed. In complement, only output is changed. If you want AB whole bar, only output is complemented. But in the dual, every 0 is replaced by 1. Every 1 will be replaced by 0. Not only at the output, but also input. That is the what we call duality. Okay, inputs also complemented. 0, 1 will give you every 1 will be replaced by 0, every 0 replaced by 1. Now you check 0, 0, 0, 1, 1, 0. Only for 1, 1 you are getting output as 1. It is nothing but AND operation. You understand the difference between this dual and complement? In complement, only output will be complemented. In the dual, both input and output will be complemented. Simple rule. Okay, so let's move further. So for your understanding, let me give you one small understanding of this. I have a function. My inputs are A and B. What is this function? Let me take it as f of AB. Last slide, second box. This one. Ready? Replace every 0 with 1 and every 1 with 0, both at input and output. Here 0, 0, 0, make it 1, 1, 1. Because dual, according to dual, 0 becomes 1, 1 becomes 0. Same for positive negative logic also. 0, 1, 1, write it as 1, 0, 0. Okay. See, output expression here is A plus B. So here it is A into B. A into B, why I haven't written? After getting, we should write. It is A into B only. Okay, it is AB only, AND operation. Fine. Okay, so let's come here. I have a function. Okay, now what I am saying is it is function f to take here one small bubble. Bubble means inverter. My dear friends, please understand here. What is bubble? Yeah, variables are not changed. Okay, bubble means inverter. So if you take 1 minute, just wait for some time, all your doubts will get cleared. What is this? Right ready. So it is function f of AB whole bar. Whole bar. Okay. Similarly, now I want to give one more function. That is dual. What is dual? If you give here A, B, in place of A, you should give A bar. In place of B, you should give B bar. In place of output, you should take its complement for the same function. Then F will become F dual. Up to this, everybody clear or not? Tell me, please. You understand the difference between dual and I'm not saying all of them are equal. Please understand, all of them are not equal. I am saying three cases. One, two, three different cases. Not all are same, please. Okay, one will give you F, one will give you F bar, and one will give you F dual. Okay, now listen here. How to get yes, Rishikesh, for third case, both input and output are complementary. Last case can be written as F of A bar B bar whole bar. This is what we call dual. Shivam, is it clear now? This is what we call dual. Inputs and outputs are complementary. Now listen here. I have this. How to get this? Is it clear what I am saying? I have dual. How to get complement? Aditya, I told na, if it is self-dual, it is same. If it is not self-dual, they are different. Nidhi, these three are representing, this is representing one function, this is representing its complement, this is representing its dual. Don't relate three. Okay, very good, Deep. You are correct. Okay. So what I want to say is this is FD, na? So I will write one figure now. Please tell me whether it is correct or not. These boxes you need not remember. Okay, don't worry in that case. I want to give you explanation with the help of this box. This is FD of AB, na? Here you are giving AB, na? So what I will do is I will add one more inverter here. If I add one more inverter, these inverters, two inverters side by side will cancel with each other, and now this figure will be how much? This figure will be equal to F bar of AB. Okay, this will be equal to F bar of AB. Okay, so now don't worry about these circles and all. Okay, don't make the things complex. Now please listen here. This circle, whatever you are having, what is its name? Yes. So I want to say like this. Whether it is box or circle, it is not having any meaning. Please understand. You have F dual, and here only inputs are complemented. For F dual, if inputs are complemented, what is the output? It is F bar of A. Okay. So now just have a look of all. I am saying don't assume all are equal. Please remove that in your mind. Forget about these symbols. This circle rectangle not having any meaning. This circular part can be replaced by FD. Okay. If you are worrying about circle, let me remove it. Don't worry whether it is circle or not. So if you have FD here, if your inputs are complemented, it will give you whole complement. That is the conclusion I want to say. This is what we call Shannon's law also. Okay, let me repeat simply here. Just listen everybody. You have one function. Okay, so complement means, I will write here. Complement means only output complemented. Okay, dual means both input and output complement. Okay, these are not equal. These are three different cases. One represent the function, another represent complement, another represent dual. Right. First three figures, everybody clear or not? Very good. Now, please listen. If I add here one inverter and here another inverter, these two inverters will cancel. If I add here an inverter, here one inverter, these two inverters and cancel. In that case, this and this will be same. Okay, that's what I write in the next fourth figure. For the dual figure I have taken, I added two inverters at the input, which will cancel these two and give me F bar of AB. Or indirectly, from this, what I understand is for the dual, if inputs are complemented, it is equal to F bar of AB. For the dual, if inputs are complemented, it is equal to F bar of AB. This is how you get the complement of the function from the dual. That is what we call Shannon's law. Read here. According to Shannon's law, complement of any function can be obtained by finding its one-time dual, and complementing each variable individually. That is, replace dot with plus, 1 with 0, and complement each variable individually. I will give you the example, don't worry about it. Now see here. You have a function f of ABC is equal to a bar bc plus abc bar plus abc. This is your function. So according to duality principle, what is f bar of abc? First take, sorry, according to Shannon's law, what is the complement is simple. First take dual. Take dual as it is. Then what to do? Complement every variable here, A, B, C, all everything complement. Now, what is your answer? Finally, A plus B bar plus C bar, A bar plus B plus C, A bar plus B bar plus C bar. This is your final answer. This is how you need to find the complement of whole expression easily. Find the dual, complement each variable individually, all ABCs. Now 1 minute please, 1 minute, hold on please. From this we can say one more theorem also called duality, sorry, De Morgan's law. In high school you might have studied this in maths. A plus B plus C whole bar equal to A bar into B bar into C bar. Similarly, A, B, C whole bar, according to De Morgan, it is A bar plus B bar plus C. It is not A bar into B bar into C. This is from duality, you can prove it also. By truth tables also, you can prove it. Okay. Previous slide, कुछ problem है क्या? A bar, B bar, C bar, C bar 2 बार ले लिया, B bar. Thank you. So now listen. He made his this theorem, this invention. He got this law, but we also made it, but we did it late, right? We made like this, but we did it late. Who made it first? He will get the credit. So that is your Shannon's law. Now you ask your doubts. I'm open to explain any doubt. Why can't you find dual? You can find dual for any function. Riti, without dual, how to complement is using De Morgan's law also you can do. Both are saying same. De Morgan is indirectly saying De Morgan is not dual. Okay. De Morgan's is not dual means actually what is the dual of this function means you should not remove bar. Okay. Dual will not touch the variables. They replace plus with dot, dot with plus. Bhavesh, what happens? You come back to the same question again. See here, to find the function complement, it is equal to dual and a variable complement. From this, you can say Shannon's law is the same as this. So Shannon's law is saying that to find the complement of any function, you can do it by finding its one-time dual and complementing each variable. That is proved here. Okay. Now in this Shannon's law, someone have doubt? Please ask me. Sushil? As if we are not working on circuit, we are working on expression. Okay. When you are implementing, please listen. You have some kind of X bar system. You want to implement X. Then what to do? Here in place of whatever the inputs, you should do depending on your requirement. Depends on the requirement. So if inputs are not in hand, we cannot do anything. Okay. Bargui dual can be used to find the replacement of the circuit. So simple example, simple application is this one. Na? You can find complement using dual. And according to dual, we'll discuss later. AND OR function is replaced by NAND. All those things will come later. And its dual will be replaced by NOR. Right, Simran? Complement means whole bar. Dual means just exchange 1 plus 0, 1 plus dot and 1. One more point I want to say. Here now you see, if it is a self-dual, what is the advantage? If it is self-dual, what is the advantage? Comment please. Is there any advantage for the self-dual while finding complement? You need not find this because self-dual may this is same as the original. Directly output complement same as input complement. Okay, I am writing here that point. In self-dual, okay, FD equal to F. So no need to find FD. Okay. Here one point I want to give you. I will give some time, maybe 2 days time or up to tomorrow. You prove it with n variables. There are I want to prove there are 2 power n minus 1 self duals. I'm sorry to write like this. What is that? I want you prove this. This I am giving you as a homework. I will prove in the class. Don't worry about that. If you have n variables, there are 2 power n minus 1 self-dual functions. This you need to prove. Okay. This I am leaving you as homework. We'll discuss in the class also. Don't worry. So let's move further. So that is those are the basic laws of your Boolean algebra. Let's start the problems. So what is the first question? Oh God. Printed is not there. I will write now. Don't. What please slide, man. Rohit, this one. In self-dual FD equal to F, so no need to find FD. That's all. So let me start the question. Simple question. A function. You see, just give me. I'll start the poll. Okay. A function f of ABC. अभी पेन नहीं रुद्राक्ष चार्जर चाहिए. F of ABC equal to AB plus BC plus is then F bar of ABC equal to A bar B bar plus B bar C bar plus A bar C bar. Okay. Now question is true or false? Yes or no? I will start the poll. Read the question carefully. True or false? Shall I start? Okay, start. Answer. Good. Let's see how much will give you how many will give you will give me right answer. Why are you commenting, man? People are participating in the poll. Elections are going on. You are giving results. Okay. Around 50% gave no, because you will feel that f of ABC whole bar is not this, sir. It should be a plus b into b plus c into a plus c. Okay, individual bars. This is according to Shannon's. Find dual complement individually. You expand this. What will you get? B bar into, sorry, B bar plus A bar C bar into A bar plus C bar. You expand this, finally what you get is the same A bar B bar plus B bar C bar plus A bar C. Actually, since it is self-dual, directly you complement each variable, you will be getting the answer. Okay, so what is the right answer? True. I told you for self-dual, if you even you find the dual and do it, or not finding, both the cases you get the same answer. So let's move to the next one. Ready? Okay. Minimize the function f of ABC equal to, yes, both methods will give same answer. See, Simran, I find dual and take individual complement. Or directly I said because it is self-dual, individual complement is same as whole complement. Both are same. Minimize the function f of ABC equal to, let me write the question, a bar BC plus a B bar C plus a B C bar plus ABC. Please do this part. We are not discussing K-map here. Okay, K-map etc. come next. First only Boolean algebra. I will give you one DPP of around, I think, 20 questions. It is uploaded. Yeah. So DPP is also ready. Poll चाहिए. Poll नहीं. Answer comment. Do that and comment your answer. Very good. So different answers I am getting. So at the end of the class, I will upload DPP. Please remind me, okay? Today at the end of the class. So let me do the question. So see here, my dear friends, if you take here, what is the common? I can take C. C common if you take A bar B plus AB bar. If you take AB common, C bar plus C. If you do like this, good evening Ganesh. If you do like this, you cannot proceed further. Okay. Actually, it is called as XOR B. We discuss that tomorrow. Logic gates. Okay. So this is not minimized. So what I will do is, listen. What is my function f of ABC equal to A bar BC plus A B bar C plus A B C bar plus A B C. Okay. Now listen. For this function, you observe here BC is common in first and last. AC is common in first and last. AB is common in first and last. So what I will do is I will add ABC here and another ABC also. So how you add? Because ABC plus ABC plus ABC is ABC only. You can add any number of times. Now in these two, what I can take common? BC. In these two, what I can take common? AC. And the second, these two, what I can take common? Here, AB. So now it is BC plus AC plus AB. This is having one important name called as 3 input majority gate. 3 input majority gate, or it is also called 2 by 3 voting logic. This is used in industries, this logic, AB plus BC plus AC logic. Okay. What is the name of this? 3 input majority gate. Why it is called 3 input majority gate, sir? Listen. Out of the 3 inputs, please listen carefully. Majida, generally we go by number system, what we call K-map. Here we should check BC can be taken common, AC can be taken common, AB can be taken common. But you have only one term. That's why I have added. Generally we go by K-map. We don't do by Boolean object also. Okay. So now see here. In this, why it is called majority gate? Let me explain that. Why it is called majority gate? 3 input majority gate. What does it mean? Majority gate means out of the 3 inputs, if majority of the inputs are 1, output is 1. Majority of inputs are 0, output is 0. I'll write here. What is the meaning of majority gates? Out of 3, majority of inputs is equal to 1, output equal to 1. Out of 3, majority of inputs equal to 0, output equal to 0. This is what we call majority gate. Whether it is true or not, you take it. AB plus BC plus AC. If B and C both are 1, output 1. A and C both are 1, output 1. A and B both are 1, output 1. Or ABC all are 1s, output 1. That is, out of the 3, at least 2 1s you should have. Then only output is 1. Otherwise, output is 0. Is it clear? That's why majority of inputs are 1, so then only you will get output 1. Majority of inputs are 0, your output is 0. Suppose your input is 1 1 0. Here A and B are 1s, na? So you will get output equal to 1. If your input is 1 0 1, then also you get output 1. Your input is 0 1 1, you will get 1. 1 1 1, you will get 1. But if your input means what? ABC. If ABC is 0 0 1, here BC is 0, AC is 0, AB is also 0, na? So in this case, your output is 0. For this also 0. 1 0 0 also 0. All zeros also 0. So majority of inputs are 0, output is 0. Majority of inputs are 1, your output is 1. That's why it is called majority gate input. Or it is also called 2 by 3 voting. You are voting, how many minimum votes you should get? Like elections, minimum you need 51%, 50%, more than 50%. Like similarly here, out of the 3, how many votes you need to get? 2 votes. Then only I will give you the answer, output. Minimum 2, कम से कम 2 होना चाहिए. 2 by 3 का meaning. Okay, let's see one example or one use of this figure. Sorry, this. यहीं पे consensus लगने के लिए कुछ condition नहीं ना? You don't have that particular case. You can try variable and its complement. Product of remaining is not available. If it is available, you can do it. Okay. So let me give you one simple example to understand this majority gate. So let's make. Say you have one process industry. This is a tanker filled with some sort of some liquid is there here. Okay. Right. Now, lemon juice, sugarcane juice, whatever you want, you can take that. Oh, all possibilities. So listen here. Here you have one burner. You are heating this. Okay. You are heating this, and I kept some temperature set point of some 1000 degrees. Whenever it reaches the transducer here, transducer means it will detect the temperature and convert into voltage and give some feedback here. Okay, it will detect the temperature, some RTD or thermocouple we call generally. Sensor will sense this temperature, convert into voltage and give some feedback to the control system, and that will stop this whatever burner or gas. Okay, feedback system is there. It will stop the gas, it will stop heating. Okay, this is some system is there. Okay, but what happens is this feedback coming, this thermocouple is there, it is not working. Even you purchase from the best company, there is a chance out of the 1,000 one may fail. If your luck is not good, that one will come to you only. Yes, or after 1 year or due to some condition, there is a chance of failure of this system. I mean, this particular sensor is not working, sir. So this fellow is heating. 1,000 has become 1,200. 1,200 has become 1,500. अभी आग लगेगा? Yes, 1,500 reached, then it may burst or it may collapse your entire system also. Now, what I do is I don't rely on single device here. Then what I will do is I will take 3 tappings from 3 sensors. From these 3 sensors, cost may increase. Okay, I use 2 by 3 logic. Now what happens? 2 by 3 logic and connect to the system, then I have safety at least. Okay, at least if one system is not working due to some reason, remaining 2 are healthy, then I will get the output and my system will work happily. Sir, if 2 goes, that is your fate, no one can help you. Sir, if 2 are not working at a time, that is your fate, no one can stop that. Okay, so yes, same question is asked by Sura, right? So here reliability increases. Okay, so like that you can check for 3 by 4 logic, 4 by 5 logic, like that you can implement it. Okay, so this is most commonly used in industries, so 2 by 3 voting logic. Okay, what is the use of this simple logic function? AB plus BC plus CA, anybody can solve, man. You should know some kind of logic behind that, where I can use this logic function. Okay, I am getting some 3 inputs. I should decision making out of the 3, at least 2 or 1. I will give 1. Okay, all the 3 are good, no problem. Okay, right. So let me upload a few more slides. I mean questions as your homework for today. Yeah, 3 by 4 different logics are possible, Nishita. Let me upload the slides. I mean for your DPP. What's happening? Not coming. Yeah. Yes, Balakrishna, after the completion of the chapter, every time I will be adding it in the Google Drive and group also. So I will be giving you a few questions for practice. Those questions will solve in the homework or I mean doubt session, or tomorrow also I may solve. Let me upload and end the class. We'll do a few questions in the class again. Swapnil, just wait. All your individual doubts, just wait. I will help. I have replied for everybody. Message me on Unacademy, I will help you. KMAP, everything we'll discuss. Kunal, we can solve definitely. KMAP, I have not explained it, so I have not discussed it. So from Boolean algebra, latest questions, whatever appeared in the GATE exam, I have collected. I'm giving you those questions. You will be able to solve definitely. Tomorrow also we'll do a few questions in the class also. Both are there. So this is DPP as you demanded. Okay, I tried to provide you like this. Okay. Yes, Simran, I will take for English batch. So 17 questions I have added as your DPP also. Few more चाहिए क्या? I will do okay most of the questions. Rohit, just wait. Let me upload and I can individually answer. So for 2 days you got some work. I mean your DPP. Happily do that. Good night. Good night. So I will do this. Please try this question. Tomorrow I will do it in the class. Anyway. Good night, everyone. So individual doubts, please stay. Remaining people can leave. Thank you very much. Thank you very much. Good night. Good night. You can ask Sora. Good night. Rohit, what is your doubt? ऊपर गया एक सेंसर कुछ डाउट है क्या प्लीज कमेंट कॉपी पेस्ट और कमेंट अगेन what you didn't understand Sura nothing to revise practice as many problems as possible just revise my notes completely and do as many questions from questions there is nothing to remember in the this one Bhargavi that I will discuss tomorrow I told now already how to identify self double that is in the SOP POS topic yesterday I have already completed the DPP. Okay, remaining DPPs wherever you have doubt in the doubt session we'll be discussing that. Where what is your confusion? Clearly ask me, Bhavnesh. I will help you. Rohit, one valve do not work. Then how sensor? You are worrying here. Valve is there. Okay, sensor is working for temperature, not for valve. If valve is not working, no one can help here. There might be some bypass. Okay, we are speaking with respect to sensors redundancy. Yes, Krishna, for English batch I will take. No need here. There is nothing to remember here in the digital. If you want, you can make that Boolean algebra expressions as one line. I don't suggest that is not required. No formulas are there here. Chaitanya, not tomorrow, Aditya. In the doubt session, we'll be discussing the DPP. Above तीन में एक नई वर्क हुआ तो भी you get 1 1 here, at least 2 ones. You get output is equal to 1. If you get 0 0 here, at least 2 zeros. Output is 0. It will work. No need Rudraksh. If required, we'll see. Okay. Generally, we can convert into decimal and do it. Your job is. You are getting 0 1 means what? 3 are 2 are not working here, Rohit. If okay, you don't get 0 1 because out of the 3, 2 are working properly means 2 will be definitely same. Rohit, please see this will occur. This will occur. Okay, if this is okay, provided at least 2 are working proper. So you are saying if this is not working here 0 1 will not come. If 0 1 comes means what? Out of these two, one is not working. What SAMS? Is it clear what I am saying? Out of the 3, 1 fail, it will work. Vivek, it is up to you, no problem. In both the places, I will upload. Is it clear, Vivek? Out of the 3, 1 fails, then only work. 2 fails, no one can help you. Okay. If 1 fails, remaining 2 should give me same, either 0 0 or 1 0, 1 1, not 0 1. It means 2 sensors should not give you wrong. Means both of in these two also 1 is failed. Swapnil, wait, I will tell you. Rohit, is it clear your doubt? Yeah, same doubt is asked. I will explain both of you. Okay, now go back. My dear friends, good night. Thank you so much. So here you might have this doubt, why ABC is added. Firstly, why I said why I added ABC is check here. If you see the original function, here BC is common with this BC. Okay. Similarly, here AC is common with this AC. Here AB common with this AB. Because of this reason, I need two more ABCs to take common between all. And another thing, you know, A plus A plus A plus A, n number of A's will give you A only. N number of A's will give you A only. That's why ABC plus ABC plus ABC is equal to ABC. Sir, if this point I don't get it in my mind in the exam, don't do that. Go by K-map. I will discuss that. Always please ask your doubt specifically. Duality means what is your doubt? Clearly ask. Where you have that point, I can help you. Definitely. I'm coming to duality. So let's go slide by slide. Check where you have in this slide. I have doubts, sir. I can help you definitely. See this slide first. Is it okay? Rohit, I suggest you two things. Download this one or follow my PDF. Our third one is you write your notes by seeing this PDF. I mean, these slides again. All the three are okay. If you write, if you have time, if you write, I will definitely appreciate. That will be best of among all the things because your own handwritten notes will be the best one. Just to see the lecture slides because on every slide required points I have already written. Every single point required for you will be present here definitely. I don't just leave any single point. So download the slide with the annotations. It will be same as notes. Yes, Rohit. So where is that Bhavesh? You are there? In this slide, you have any doubt? Can I move to the next floor? Next slide. Good night, Rohit. Swapnil, message me in an Academy app. I will help you. Not own language, copy the similar thing. Okay, don't change it in the sense. Own language doesn't mean don't change the things. Okay, right. So to find the dual of this, what you have to do? Replace simply. Don't touch the variables. Yeah, this one. To find the dual, here there is no concept of complement. To find the dual, what you do? Replace dot with plus, plus with dot. Only this thing. Don't touch any variable. As it is, you take the variables. Thank you, Swapnil. I hope it is your first class. Okay, that's what I'm saying. It is two times if you apply it, you get back your original. For some functions, one time will give you same. This slide is okay, Bhavesh? Let's move next slide. I told about positive negative logics. Now, this is important. When you convert a positive logic into negative logic or duality, okay, thank you, Swapnil. Replace every zero with one, every one with zero. In this whole table, replace all zeros with ones, all ones with zeros. This is what we call duality. Please see simply, if you take only output complement, 0 becomes 1, 0, 0, 0. This is complement. Complement don't touch the inputs, only output will be touched. If you touch both inputs and outputs, then it is called dual. Bhavesh, is it clear? Okay, then you will not be getting any doubt now. But yeah, what is that? You see here, if you take only output complement, it is a complement. If you take both input output, it is dual. My dear, we are not converting here. Okay, you have a system in positive logic designed. You are using in negative logic. Then this AND gate will work like a OR gate. If you use this designed system in this method or this designed in this method, then how these functions are changing? That is what we are discussing. Okay, you are reading 5 volts as 1, 0 volts as 0. But if you read reverse, how you should understand? OR gate will become what? Okay, because every system will not be working in the same na. If I get 5 volts, I am assuming it as 1. If I get 0 volts, I am assuming it as 0. I may assume reverse also na. Why should I read 5 as 1 and 0 as 0? I design my circuit in the reverse case. Then OR gate will become work as AND gate will work as a OR gate. Okay, done. So this is a simple one. If you take output, it is complement. If you take both input output, it is dual. You see here simply, it is a function. You take only output bar complement. Suppose you assume it as an AND gate. This will be NAND gate. What about this one? It is the dual. Okay, see here. You take AB. This one is AB bar. What about this one? A bar into B bar whole bar. Input output complement. This will give you A plus B. By De Morgan's, A bar B bar is A plus B whole bar. Both will cancel. Yes or no? This cancels with this one. These two cancels. What is the answer? So you see AND gate will become OR gate. Is it clear? Input and output both are complemented because you see here what I did. 0 at input and 0 at output both are changed. Good night, Chaitanya. First three clear or not, Bhavesh? Tell me. What's happening? Yes, it's clear. Then see here, I replace. If I keep two more bubbles here, these two bubbles cancels. And again you will get this complement. So what I want to try is I want to make one circuit for complement using dual. That's all. If you keep here two bubbles, what happens? These two bubbles cancels. Bubble followed by bubble is inverter. X bar whole bar is X. Complement these two. Then what happens? It is equal to same figure or not? You take here bubble, here bubble. If you take, then same. That's what I said. For finding complement, dual input should be complemented. For the dual circuit, if you complement input, it will do same job as original second figure. That is what we call Shannock's law. Okay, right. So it is clear. Thank you, Alchan. So let's end the class. Good night. Good night. We'll meet tomorrow. Thank you very much.